Hey guys, Umongus here, and this is part 2 of data structures. Part 1 was about an array list, which we programmed here. Now, as you remember from the array list, every time we added an element, we would make it sort so that at the end, the array list would be in order. And now I've made a few changes, such as now it adds random numbers, and so for the two functions insert and add random nums, I put a variable called int list, and if it's set to 0, that means array list, and if it sets to 1, then linked list. And here's the new results. Yeah, so it adds about 16,000 integers ranging from 0 to 99. And yeah, as you can see, they're all in order, despite each number being picked out of random. And yeah, I've also made it so that the array list can increase its capacity, which you've also seen me done for the previous programming series of an assembly code simulator. Oh, and also later on I'll be releasing a separate video where I just make a bunch of demonstrations with the assembly code simulator that I wrote, and I'll also release it for download. But yeah, anyways, here we are. And now it works with the really large array list, 16,000. Now if we were to make it even larger, let's say by a factor of 100 or even thousands, then this is going to make the program run really slow, because as each number is being entered and it's being sorted, the number of time it takes to add a new number and to sort it so that it gets put in the right position increases whenever the array gets bigger. So surely we're going to make a linked list and then run it. And yeah, it's also going to be pretty much the same process when it comes to adding numbers, where again we're going to add numbers and then sort them. So I'm gonna try to compare the time it takes for each one. So first off, we're gonna need to include time.h, and then it has a function called clock t. Well, it has a type definition of clock t start, and then after all of it runs, and then I'm gonna we could also record the time at clock t end, and yeah, so basically it's gonna record the amount of time that it takes to add 16,590 random numbers. We might as well just make it even larger, and yeah, we're not going to be printing anything anymore. Alright. So then for each of these clock t variables, and then equals clock, and then clock t end equals clock. And then we're also going to have to print out the total amount of time taken. So I'm going to create a double variable, double time taken, which is going to then equal and you're going to have to typecast it as a double, and then the variables end minus start, since these are clock t variables and then being typecasted into a double, It does time taken, and then we're gonna want to print out the time taken, so printf well, let's put it all the way at the bottom. Printf, and then new line, time taken, and then since we're trying to print out a double variable, which is a number that can be in decimal form, %.2f float, where the f means float, and let's run the program. Alright, so when I ran the program, it's taking forever pretty much, so let's set it back to this number. Oh, and that's another thing, later on we'll try different values of this, which means a different number, a different capacity for the array list, and then we're going to see how the speed changes, so let's say later on if we let's make it a number that's easier, so set it to 20,000, and then let's see if we're also going to try 40,000 later on, and then measure the amount of time it takes for each, and surely the 40,000 one is going to take longer than just twice that of the 20,000. So yeah, let's try it like this. Let's see how long it takes. Right, so it took 440. I'm guessing it's a second divided by 10. So we're not actually sure what unit of time is being measured here, because it definitely feels way longer. But anyways, now I'm going to make it add 40,000 numbers instead of just 20,000. And let's see how long it takes now. $17.15, so that's way more than just twice. Right, so we're also gonna try to keep track of that as well. So we're gonna write down a text file, array list, linked list, and for the array list, 20,000 insertions, 40,000 insertions, 440, 1715, let's just say milliseconds, even though it's definitely way longer than that, and then save the file. Alright, well now after looking it up on the internet, I now know what I have to do about clock t. So there's a variable called clocks per sec, and so now instead of just these integers that don't seem to mean anything, we're gonna get the number of seconds it takes. So then we take all of that and then multiply it by 1000, and then it's gonna give me the amount of milliseconds taken. Alright, now I found the fix. So write this exact line, double time taken equals, and then you put a typecast to end minus start, and then separate it off right here, divided by clocks per sec, and then when you print it, use time taken and then multiply it by 1000, and this will give you the number of milliseconds. Alright, so now what you should do is try this here with various different numbers, 10,000, 20,000, 30, and yeah, just keep repeating. Alright, now after running the program 10 times with these 10 different numbers of insertions, each divisible by 10,000, and I've found these amounts of time that it takes. So at 10,000 insertions it takes 106 milliseconds, and then at 20,000 it takes 433, 30,943, and this seems to be squared because 1 squared is 1, 2 squared is 4, and then 3 squared is 9, and then 4 squared is 16. So yeah, it seems to be an exponent of 2 in the amount of time it takes, increasing for the number of insertions needed. Alright, and linked list will actually now be part 3 of this programming series, because it's going to be kind of awkward putting, let's say, timing and linked list both in the same part. So yeah, part 3 is going to be about linked list.